Hello all. In this lecture, I'll be discussing about the conversion of a DFA representation to a regular expression using the state elimination method. So in DFA, we know that we have states, and with an input symbol, there can be a transition between one state to another. So this DFA is to be converted to a regular expression. So this is about the introduction of what is to be done. Okay, an algorithm of how we can convert a DFA to RFA using state elimination method. Now, before we convert a DFA to regular expression using this state elimination method, let us refresh the equivalence of DFA and their regular expressions. So if you see this, this is the union operation. So I'm in a state X and I'm moving to state Y. Now there are two paths. Either I can take A or B path, which means with an input A, I'm transiting to the next state, or with a different input B, I'm transiting to the next state. So the equivalent of this DFA representation is A plus B, or I can also represent it using A pipe symbol and then B. The same can be represented as from the current state, if A or B, whatever is the input, I can transit to the next state. So I can have the same representation of the regular expression A plus B or A by B. Now this means it is the union operation A or B. Now this is from the current state. If A is given as the input and it still stays in the same state. Okay, so any number of times A is taken as the input from the current state, it stays in the same state. So this is represented with A star, which is 0 or more occurrence of A. Now the last one is concatenation. First, with an input A, I am moving from the current state to the next state. Then from that next state, if B is given as the input, I am moving to the next state. So the equivalent regular expression is AB. Now let us take an example. We are going to convert DFA to regular expression by eliminating the state or state elimination method. Now let us consider a state S. I'm in the state S, and with an input S, again I remain in the same state, which means S star. Now let Q1, small q1 and q2 and so on till qk can be some states which is having an input such that it transits to S. So say the input can be capital Q1 to QK. Now from S, if some input say P1 or P2 or PM is given, it moves to the next state, say P1, small p1, P2 and so on till PM. Now this from this Q1 state or from Q state through S, if it is moving to P state, you can see that Q1 or P1 is the transition. If there is no transition from Q's to P's through S, then say the transition is R. So this 1 represents first state of Q1 and first state of P1. Similarly, kth state of Q and mth state of P is represented as RPM. So the input RKM is given to QK such that it is transiting to small pm. And So this R is the transition from Q to P directly without transiting through S. So R is the transition from R1M is the transition from Q1 to PM. Similarly, RK1 is the transition from QK to P1. So these are how the transitions are happening, where you have Q number of states, which is giving its which is having its transition to S, and there are so many states P's where an input from Q is transiting to P. And there are states from P to Q directly through some symbols R's without transition to yes. Now, if I'm going to eliminate a state S, which means that I'll have to eliminate all the inward and outward transitions from and to S. In that case, I cannot simply remove this S state and these transitions, Q's and P's. So I will have to replace it. So let us see how that can be done. Consider I have removed this state S, and I'm removing all these transitions from S to other state and to S from other states. And if such a transition and state is removed, then I'll have to replace it. So let me take states Q1 to QK and P1 to PM. Now, if first let us see this transition Q1 to P1. So when Q1 to P1 is the transition, then one path is through R11. The second one is I can take this path Q1, yes, and then P1. So this is union operation. I can either take R11 path, or I can take Q11. How many ever times I want, I can transit in the yes state with S, right? S as the input. Then from S state, I can move to P1 through P1 input. So it is R11 plus Q1 S star P1. So I can take this path or this path. So that is the representation R11 plus Q1 S star P1. Next, let us consider this transition. So this transition is RKM, okay, this transition plus QK S star PM. So RKM plus QK S star PM. Next, let us take this transition Q1 PM. So for this, I can first transit through this, which is R1M plus Q1 S star PM. Okay, so R1M plus Q1 S star PM. The next transition is from QK to P1, which is RK1, okay, RK1, then QK S star P1, QK S star P1. So this transition, like this, you can make the transitions. These are the steps how you can transfer the transitions if you are removing a particular state and their transitions. So next we will discuss the algorithm, how to convert DFA to regular expression. So the first step is we need to eliminate all the states except the starting state and the final state. So usually start state is represented using Q0 and final state is represented using QF. Next is step 2 is, now we only have two states, Q0 and QF. If both the states are different, which means Q0 is not equal to QF, it means that I have a start state Q0, I have a final state QF, and start state is represented using a inward arrow towards the start state with the start label. Now I can have any number of transitions from the start state itself with a particular input, so which is represented as R. From the start state to the final state, there can be a transition with the input S, and when I'm in the final states with an input symbol, I can move from the final state to the start state. Say the input symbol is T, and with any number of input U, I can stay in the final state itself. So these are the four possible transitions. Now the equivalent regular expression for such a DFA is here, as you can see, R, then plus yes, U star, then T. So this can happen any number of times. So that's why it's mentioned as star, then finally yes and U star. This is the equivalent regular expression for the given DFA. So I repeat, R, yes, U star, T. This can be done any number of times. So that's why you have a star. And then finally, yes and U star. So for this DFA, this is the equivalent regular expression. Now the next case is when Q0 is equal to, when Q0 is equal to QF, which is the start state and the final state are the same. So it is represented like this in your DFA, where you only have one state. So when you have double circle, you call it the final state. The start state is represented using this arrow and the start label. So both these states are the same, start state and the final state. Now an input an input R is given and it stays in the same state. And this can happen any number of times. It means that it can be represented using R star. So means that epsilon, which is zero number of occurrence of R or one occurrence of R or any number of times R can be given as the input. So that is step 3. Now coming to the step 4, which is the final expected regular expression can be obtained using the union operation, union of all the expressions derived for each accepting state. So this is the algorithm that is to be followed in order to get the DFA representation to the desired regular expression representation. In the forthcoming lectures, we'll discuss some examples. Thank you.